Our last topic in Chapter 1 is on decomposition of a function. Decomposition is the opposite of composing a function. What we're going to do is we're going to be given a relatively complicated function and we're going to be asked to break it up into two other functions. And in order to do this, we need to identify an inner and an outer function. And we'll go through this in a couple minutes. But first, I want to show you that we're going to be composing two functions, doing composition. So I'm going to have you recall composition. And then after we do composition of two functions, then I'll show you how to decompose that same function into the original functions. So, for example, let's say we're given f of x is equal to x squared, and g of x is equal to 3x plus 2. And if I want to compose those two, or if I want to know what f of g of x is equal to, I take the g of x function, which is 3x plus 2, and I plug it in for x in the original f function. So what I would get would be, 3x plus 2 squared. Our second example on composition, let's say f of x is equal to the cosine of x. And let's say g of x is equal to x squared plus 1. And if I wanted to do composition, f of g of x, I would take the g of x function and replace this x in the cosine function, so we would get the cosine of x squared plus 1. This is composition. This is stuff that we've already done. You did it this year and you did it last year. And one additional example, we'll say f of x is equal to e to the x, and g of x is equal to x squared plus 2x plus 3. And if I wanted to put those together as f of g of x, I'd take x squared plus 2x plus 3 and plug it in for that x, and I'd get e to the x squared plus 2x plus 3. So what our job is going to be is to take this composed function like 3x plus 2 squared, cosine of x squared plus 1, or e to the x squared plus 2x plus 3. We're going to be given those functions and we're going to be asked to decompose them. So in order to decompose a function into two less complicated functions, you must identify an outer and an inner function. The outer function is often the general or the simpler, higher level parent function. The general, simpler parent function. Like y equals x squared, y equals x cubed, y equals the absolute value of x. You know all of our parent functions. And just by convention, let's call the outer function f of x and the inner function g of x. So let's suppose we're given h of x. H of x is our complicated function. Let's say we're given h of x is equal to 3x plus 2 squared, and we're asked to decompose this function. into f of x and g of x. So we take a look at this function and we say, well, the parent function of this would be something is squared. What is squared? The inner function is squared. So we take a look at what is it that's squared? Well, it's the 3x plus 2 that is squared. So we can say our outer function is x squared. Something is being squared. Our inner function is 3x plus 2. That's the thing that's being squared. So we can set x squared equal to our f of x, our 3x plus 2 equal to g of x, and if we did f of g of x, we would get our h of x value. So what we've done is we've decomposed h of x. H of x is equal to f of g of x. Second example, what if we're given h of x is equal to the cosine of x squared plus 1? Well, we take a look at this and we say, well, there's an outer function and an inner function. The outer function, it looks like outside this function is the cosine of x. And it looks like the inner function is x squared plus 1. So we'll call our outer function cosine of x. And what are we taking the cosine of? We're taking it of the inner function, which is x squared plus 1. And we can let our outer function be f of x, our inner function be g of x, and if we did a composition, f of g of x, we would get h of x. And then the last example, like we did above, let's say h of x, what we're given is e to the x squared plus 2x plus 3. What is our basic parent function? Well, our basic parent function is e to the x. E is being raised to some power. So our outer function, our parent function, is e to the x. Our inner function is what is e being raised to? X squared plus 2x plus 3. So we can call e to the x f of x. X squared plus 2x plus 3 is equal to g of x. So what we did was we did a composition and then we did a decomposition of those same functions. So now let's try a couple of other ones. Let's say we're given h of x equals x cubed minus 3x plus 9, all raised to the 10th power. A lot of times the inner function is what's inside parentheses, and what's inside the parentheses, x cubed minus 3x plus 9, what is being done to that function? Well, that function is being raised to the 10th power. So the outer function is something is being raised to the 10th power. The inner function, what is being raised to the 10th power? Well, x cubed minus 3x plus 9 is being raised to the 10th power. So we can call x to the 10th f of x, and then g of x is x cubed minus 3x minus 9. I'm giving you several examples so you can get comfortable with this. And if you did f of g of x would be equal to h of x. Here's our next example. Let's say h of x is equal to the cubed root of 2x plus 1. Well, what's an outer function? What is the overall function? What is overall being done here? Well, overall, we're taking a cubed root of something. And what are we taking the cubed root of? We're taking it of the inner function, 2x plus 1. So we can identify the outer function as the cubed root of x, the inner function as 2x plus 1. And if we did a composition f of g of x, then we would get our h of x back. And then we'll do one more example. We'll do a trig example. Let's say we're given h of x is equal to sine squared of x. Oh no, let's make it a little bit more complicated. Let's say sine squared of x to the fifth minus 6x squared plus 1. So what is the overall function? Well, normally we would call it sine of x if we didn't have this squared in here. But we can actually call our outer function sine squared of x. That would be fine for an outer function. And then what are we taking the sine squared of? We're taking it of our inner function, which is, usually it's left in parentheses, x to the fifth minus 6x squared plus 1. And if we let sine squared of x be f of x to the fifth minus 6x squared plus 1 be equal to g of x, then if we did the composition f of g of x, we would get our h of x back. So the reason why we need to do this is later on when we're working through some of our calculus examples later on in this year, we're going to be given sometimes a very complicated function like sine squared of x to the fifth minus 6x squared plus 1, and we're going to be asked to do some calculus on a complicated function, and it'll make it a lot easier if we can break it apart into two smaller functions, two smaller, less complicated functions. And that's the end of this lecture, and that's the end of Chapter 1.